Okay, students, so I'm going to help you do this homework assignment. For those of you who are not taking my class, I'm going to post this worksheet on my website, which is halverscience.net. So let's just write that someplace. Okay, my website is halverscience.net. And I'll put this worksheet and you can follow along. Okay, so what we have here is a hypothetical particle with a kind of a strange looking potential energy curve. Now, I made this so it's sort of like a molecule, once again, a diatomic molecule. But of course, in real life, you wouldn't have all of these straight line segments. And okay, so let's I'm going to be reading the questions on a piece of paper here because I don't want to have to move my graphing around. So the first question, well, let's read what it says. A 1.5 kilogram particle is in a potential U of x, which is what I've just graphed there. It starts at x equals 26 meters, so it's starting here, right? This is our starting point. And it has a velocity of -2 meters per second. So it's moving to the left at this speed, right here, at 2 meters per second. Compute the energy of the particle. Okay, now I suppose I should say this is going to be the mechanical energy, right? We're not talking thermal energy. So the mechanical energy, E, is equal to the kinetic energy plus the potential energy, which is going to be 1/2 mv squared plus whatever u is, u at 26 meters, all right, which is going to be 1/2 times the, how many kilograms? 1.5 kilograms, 1.5 times the velocity, which is 2 negative, but that doesn't matter, it's squared. But you're going to add to that the potential energy, and the potential energy, oh my God, it's 0. So we're just going to add 0 here. Okay, so let me pause this. If you did 1/2 mv squared, where this is the velocity here and the mass is 1.5 kilograms, you get 3 joules for the kinetic energy, and as we were mentioning before, at 26 meters you have 0 joules, so you get a total of 3 joules for the energy. Okay. Now, the next, number 2, it says, draw the energy level of the particle in the first graph. So what you guys need to do is you need to have printed out a copy of this paper, and you're going to need a ruler. I'm looking for a ruler. Here it is. I found my ruler. So you're going to get a ruler, and you're going to put it down, and I want you to put the ruler at 3 joules. So here we go. 1, 2, 3. All right, 3 joules, and draw a dash line. So dash, dash, dash. Yeah, okay. And this dash line is analogous to an energy level in chemistry, how much energy a molecule has. So the energy level of the system right now is 3 joules. So I need you to label this. E equals 3 joules, all right? So label everything so you get all of the points, right? I grade the homework. this is practice for an exam question, okay? So you need to be paying attention. All right. So then, now that we've drawn that, let's move on to number 3. Compute K, that's the kinetic energy, in region F. Okay. So what is the kinetic energy here? Now, there's definitely a trick that you need to understand about this, right? So what we're doing is we're saying, look, we know E equals K plus U. And we know that it's 3 joules here, right? It's 3 joules at this location. But according to the law of conservation of energy, if there is no friction, the mechanical energy will be constant. So this mechanical energy is going to be 3 always, right? Until you like take away some energy or put in some energy. But for now, it's going to just stay stuck at 3. So when you ask the question, what is the kinetic energy here? Well, we could do it this way. We could say, all right, K equals E minus U. Now, E is 3. It's always going to be 3 minus U. And you look at the graph, and the U right here is 1. So it's going to be 3 minus 1 equals 2 joules. So the kinetic energy, let's use a different color. The kinetic energy is graphically this much. And the potential energy is this much. And you see, so this much potential energy plus this much kinetic energy is adding up to the 3 joules. Okay, that was supposed to be part of a dotted line. Okay. Okay, I hope that made sense. Just to reinforce that, let's suppose that this was a ball and it was rolling along. When it hit this slope, it would have slowed down, right? So its kinetic energy would have been less, right? It started out with this much kinetic energy, but then it rolled up the hill. Now it has less kinetic energy. It's traded some kinetic energy for potential energy. Okay, so that was number 3. Number 4. Compute the velocity in region F. Okay, well, to find the velocity, right, you have K equals 1/2 mv squared. You solve for v, you get v equals the plus or minus the square root of 2k over m. And so it's going to be plus or minus the square root of 2 times 2 joules over 1.5 kilograms, which you do the math and put in a calculator, it works out to 1.633 meters per second. Now, that gets us the velocity, but notice that there's 2 possible answers. The particle could be moving to the right at 1.63 meters per second, or it could be moving to the left. Either one is a legitimate answer. Okay, let's keep going. Compute K in region C. Well, to figure out the kinetic energy in this area here, you could go through the same thing. You could say the kinetic energy is going to be 3 joules minus the potential energy. But the potential energy is negative here. It's negative 4. So it would be 3 minus negative 4, which would be like 3 plus 4. So it would be 7 joules. But that's fine. Okay, that's great. You get the answer, 7 joules. But let me show you an easier way. The easy way is to just realize that just like here, the kinetic energy was the distance between this potential energy and the energy level, the total energy here, is the same thing here. So the kinetic energy is the kind of the distance in energy between the potential energy and the total energy. And now this is on a convenient graph. Just count them up. 1, 2, 3, 4, 5, 6, 7. The answer is 7 joules. Okay, that's the amount of kinetic energy. Okay, so 4, 5. Okay, and then for number 6, you're going to go through the same process. And okay, that takes us to number 7, in which it says, in the second graph, draw the force, f of x. Remember that plus is a force to the right and minus is a force to the left. And the force formula is that the force is equal to the negative of the slope. Okay, so let's do that. So let's start with, let's do the easy parts. Let's do that first. So here, the slope is 0, right? So you know that the force from here to here is 0. Okay, let's do an easy one. I'm not going to do the whole thing. You're going to finish it off. What's the slope here? Well, it goes down 4 joules, and it goes how many meters? Let's see, each one of these is a meter. 1, 2, 3, 4. Ooh, the slope is -1 joule per meter. All right. So, but remember that force is equal to the negative of the slope. So -1 joule per meter of slope turns into +1 joule per meter. So let's go ahead and draw. There's 1. So from here to here, the force is 1. Let's do one more. Here, the slope is, it goes up 4 and it goes over 2. So the slope is +2 joules per meter. That means that the force is -2 newtons. Right? And did you know that the units of Newton are equivalent to the units of joule per meter? Yeah, that's pretty cool. Okay, so I've started it for you. I expect you to finish this, and if you have problems, ask me for help. But I don't think, you guys are smart. I am pretty sure you'll figure this all out. There is a slightly more challenging one. There's another part to this worksheet, and what I need you to do is to graph this curve here, and I can tell you that this is a parabola. It's a quadratic, and it's going to wind up looking like this. It's going to near up like this. But you guys do, you be careful. You draw it nice and carefully. Okay? And all right, so that's it for now. Study the book and look at my lectures, and I'll see you next time. Thank you. Bye-bye.